So now that we understand significant figures of individual numbers, what happens if I want to do some math with those individual numbers? How do significant figures play out with that? So let's talk about when adding two numbers together. So first thing we got to do, we're going to do what we've done since we first learned math. We're going to stack the numbers on top of each other so we can add them. And we got to make sure that the ones line up with the ones column, the tens line up with the tens, the hundreds line up with the hundreds, and so forth. Then we just do the math. Our final answer is going to be rounded using the place value of the least precise input. Least precise input. So here's an example. If I take 100 plus 5, that would be my least precise number in this is in the hundreds place, and my more precise is in the ones place. If I do that in math class, the answer is 105, and that's what you should get. If you're in math, say it's 105. But if we say use significant figures and my 100 really wasn't measured very accurately, what I need to do is I need to say, well, if hundreds place is my least accurate, then adding a 1 to something that's not accurate except for in the hundreds means that my final answer is just 100. So another example to maybe drive home this point would be if there was a car and it had an odometer on it, it tells it how far you've driven. And after driving home from work to the driveway of your house or this person's house, the odometer reads 12 miles. The person then gets out of their car and they walk to their front door, which is another 50 feet. How far has the person traveled? Well, you might say, well, it's 12 miles plus 50 feet. But you have to remember that the odometer wasn't accurate to the foot. For that first mile that you drove, the odometer read 0 miles. And then as soon as you hit 1 mile, it rolled over. So then it said 1 mile for a while. Who knows when it rolled over to 12 miles? An extra 50 feet probably isn't going to do a whole lot to it. And so since the 12-mile measurement isn't very precise, adding an extra 50 feet, which is way more precise to the total distance, isn't really going to change the original value of 12 miles very much. So here's some work problems. I have 15 plus 7, and what I should get from this is 22. But what I need to see is what is my least precise place value of each of these numbers. In this case, it was the ones column for the 15, and it was the ones column for the 7, which means my final answer doesn't change. If I were to do the math of this second problem, I would get 113. Least precise of my first number is in my ones column. The least precise spot in my second number is in my tens column. That means my final answer here can't have anything in the ones column. It's not precise enough to tell me any information about that. If I included that, I'd be lying. I'd be saying that I knew for a fact that there was a 3 sitting there, and I just don't, because that 10 isn't precise enough to tell you definitively that it's there. So now what I have to do is I have to round. I have to get rid of this 3 somehow. The question is, do I turn that 3, when I turn that 3 into a 0, what do I do to this 1? Do I keep it a 1 or do I round that up to 2? Well, we're going to use our rounding rules that we used throughout math, which is if this number is 5 or more, we're going to round up. If it's less than 5, we're going to round down. And since it's less than 5, we're going to do 110. All right, a couple more real quick. I have 1.03. This is in my ones column. This is in my hundredths column. That means that, well, this stuff really isn't important. My final answer is 1. And then lastly, 63.3. Least precise spot is my tenths. Least precise spot is my tenths. My answer is 63.3. All right, so that's adding. It also works with subtracting as well because we kind of got rid of subtracting, right? We said, hey, we're just adding negative numbers. Now what about when we're multiplying? What we're going to do is we're going to multiply numbers like we normally would, but we're going to determine the number of significant figures for each of our inputs. We're then going to figure out which of our inputs has the fewest significant figures and how many it has. And that number of significant figures will also be used for our final answer. So here's our example, 23 times 3. 23 has 2 significant figures, 3 has 1. When I multiply that out, I get 69. But I'm only allowed 1 significant figure in my answer because, well, that was the number that had the least number of significant figures in it from the problem. So now I have to figure out, do I turn 69 into a 60 or into a 70? Well, I use my rounding rules. I pick 70. All right, so here's some work problems really quick. 73 times 40, 2,920. That has 2 significant figures. This has 1 significant figure. So what I have to do is I have to round this number here to 1 significant figure, and that rounds to 3,000. Right, because this was my 1 significant figure. That was the least significant figures I had in the problem. All right, this number here has 3 significant figures. This one has 2. Right off the bat, I know that that means my answer can only have 2 significant figures in them. If I do the math here, this becomes 9.636. This 3 is less than 5, which means I can just cut it off and say my answer is 9.6. Last problem. 3 significant figures, 3 significant figures, 2.3754. That means I need to cut these numbers off here, but since this is 5, I'm going to round my 7 up. And that's how to use significant figures when we are doing our math operations.